This time, it's going to be different from what you are used to on this channel. This will be a hands-on coding session where we solve a simple problem in an interesting way. Hello everyone and welcome back to Cup of Code. It's been quite some time since I last posted a video, and it has various reasons, but the short version is that I didn't have the energy or the time to do new videos. On the other hand, now I would like to start something new, something that will be very different from morning commute, because it was a nice format, but now post-pandemic we don't have as many conferences. It's much harder to come across famous engineers and have them sit in my car, right? And also it probably wasn't the best format, so maybe we can experiment around with some other formats and see which one works better. So this series is going to be hands-on coding. We are going to look at the same problem over and over again and see different solutions, because I've been facilitating these code retreats, and what I realized is that for this very simple problem of Conway's game of life, there are so many different solutions. You can solve it in hundreds of ways, and each solution has its advantages and disadvantages. So what I would like to do in this series is look at a couple of these solutions and just see how they work and what we end up with under different restrictions to our code. So what is Conway's game of life? Conway's game of life is a cellular automata, which means that we start out with an infinite grid, and on the grid we will have some cells that are alive, usually a finite number of cells that are alive. It doesn't have to be finite though. And then for each generation we are going to generate the next generation from the previous one by a set of rules. So these rules look like this. If a cell is alive and it has less than 2 neighbors, we are going to kill that cell. It's not going to be alive anymore because it was lonely. Then we have a living cell with two or three neighbors. In that case, it's going to stay alive. And with a living cell that has more than 3 neighbors, it's going to be overpopulation, in which case the cell won't be alive in the next generation either. Now, the last rule is usually the hardest thing to implement and the most interesting one, and it says that if a cell is dead but has 3 neighbors, exactly 3 neighbors that are alive, then this cell is going to be alive in the next generation too. So once we have these rules, then we can generate a couple of these states or generations and look at the result. It's a nice animation. But in this series we are not going to worry about that. We are not going to write UIs, or we're not going to show what each state looks like. We are just going to focus on the business logic that is generating one generation from the previous one. Okay, so this first episode will be very simple. We will try to do it like a junior developer would do it, without any fancy features of the language. We are just going to use for cycles and ifs and simple functions, really a very basic procedural algorithm, and our data storage is going to be very simple as well. We are going to have a finite world, despite the rules saying that it should be an infinite world. We are going to go with a finite world this time. And we are just going to store it as a 2-dimensional array. So to get started, I'm going to start writing tests, and I'm going to do this in TDD because that makes sense with like these little exercises. So we are going to describe the game of life, and then we are going to specify, well, the first rule of course says that a cell that is alone will die, but there is a simpler test than that, and that has to do with an empty world. So an empty world, specify that empty world evolves to empty. So let's look at this, and our test will, so at this point I can run the test. Of course it's going to be green because there is no logic in here, but let's start with something simple like creating an empty world, and then as I said, I'm going to represent the world as a two-dimensional array. Okay. So it's an array of arrays, nothing very complicated. And then we are going to call the evolve function and pass it the empty world. What we expect is that it's going to generate the next generation, right? Now, of course, at this point our test is failing because we don't have the evolve function. So let's create it. Normally I would separate production code out into a separate file, obviously, but here we are just practicing now, so let's just keep it in here. No reason to move it outside. And then I'm going to expect that the result equals to, well, the same thing, right? An empty world evolves to an empty world. Okay, so oh yeah, empty expect is not defined, so I have to import expect from expect.js. Okay, and now we have an actual test. Expected undefined to sort of equal all zeros, right? So the easiest way to pass this test is to just return the empty world, which actually in this context it should just be code world, because it is not going to be always an empty world. Okay, so that's our first test, and of course for now our code does almost nothing, but we start writing more and more tests, and as this test gets more specific, our code gets more generic, right? So we specified that a lonely cell dies. That is supposed to be our next test. This is actually the first rule, right? This is the nice thing about a properly done TDD, that you can go through the requirements and just write the test for each of them. Okay, so now that we have that, we can just copy and paste this here. Instead of an empty world, we are going to have a world with a single cell, and yeah, the result should be an empty world. So here we pass in the world, and well, the empty world, maybe I also need that here. For now I'm just going to duplicate this. Maybe later we are going to do it in another way, but yeah, so what you can see now is that it's failing, and of course it's failing. Now how can I pass this? Well, both cases return the same result, so I can just copy and paste that result in here. Okay, then let's do something that returns something else. So let's specify that a cell with 2 neighbors stays alive. Okay, and that test will look like this. We take this here, this whole test, and of course we need to have 2 neighbors there, and the result should be that this center cell stays alive, right? Okay, that's actually failing, and it's failing the way we expected. The center cell is dead. Okay, well, to satisfy this test, what I'm going to do is I'm going to just extract this part into a variable called new world, and what I'm going to do is just add an if statement that says if world 1 0, which is this here, if world 1 0 equals to 1, right, we are representing this as zeros and ones, so we can actually add these. So if it equals to 1, then we are going to just say that new world is 1 and 1 equals to 1. So we are just going to make that a live cell. Okay, so now it's passing. But I feel like refactoring at this point, because here this one is like, it seems so coincidental that we are using ones and zeros for living in dead cells. So how about we create a constant alive for 1 and another constant dead for 0. And now I can just copy and paste this in here, and our test looks much nicer, right? I would be tempted to replace this as well, but I actually have a different plan with this, and you will see in a moment why I'm not going to do that replace. On the other hand, here it's kind of hard to see what each of these words look like. So I'm going to do a little trick here. What I'm going to do is I'm going to define a variable called underscore, and it's going to be a synonym for dead, and another one x, which is going to be a synonym for alive. And actually I'm going to move that into the scope of the tests, because we actually only need this for the tests. And now what I can do is I can just take this whole part and do a quick replace. All of the zeros should be replaced by an underscore, right? Okay, replace all. And in the same area, all of the ones should be replaced by an x. Replace all. And what you see now, it's like this reads much nicer, right? And actually I accidentally forgot this one. Okay, so our tests starting to read really nice, our production code starts looking really nice, but of course we are cheating, because right now we are not checking if there are two neighbors, we check if there is a specific neighbor around. So how about we write a test that specifies, and actually I'm going to write this here, because this way the test will follow with the number of neighbors and not in the order that we wrote them, but I think it's a nicer structure, so I'm just proactively reordering things here. So we test that a cell with a single neighbor dies. Okay. And then what we can do, of course, is the same structure. Actually, I'm starting to feel that maybe we should refactor at some point and write like these data provider tests. But anyway, what I can do now is I change this one cell to dead, and by that this cell only has one neighbor, so it should be dead. On the other hand, since our code only checks for the one of the neighbors, this is going to fail, right? So to fix it, I'm just going to say, all right, you got me. I need to check both sides, and it should be 2. And now you see where I'm driving at. Like, this is the reason I didn't change this one to an alive, because what I'm driving at is this part becoming our little function called count neighbors. And this refactor actually shows where we are going, right? Now, of course, having 2 neighbors isn't enough to make sure that someone is alive. It should also be alive itself. So we actually should write one more test here that will check that a cell with 2 neighbors, or that cell with 2 neighbors stays dead or does not spawn. And now I can just replace this with an underscore and here as well. And now what I will see is that, like, this doesn't work, right? Because right now, even if we just have the 2 neighbors, that's enough. Okay, so how do we change that? Well, we can just go ahead and say world 1 and 1 should be alive. Okay, so that's nice, because now we actually have the first rule. If a cell is alive and has 2 neighbors, it's going to stay alive. Then we have another thing that catches my eye, and it's this part, because we actually have a duplication here, and of course we will have to add more and more of these. So we should somehow make sure that this works nice, and we don't have to duplicate, like write down world 1 0 so many times. So what I want to do is create a for cycle here. And of course this is, if you look at the actual case, this is just a middle line. So actually we can rephrase this as world 1 0 plus world 1 1 plus world 1 2 minus world 1 1. So this is, of course, I added word 1 1 and I subtracted word 1 1, but the thing is that in this 9 or 3 by 3 thing, everything will have to be added except for this middle thing. And instead of just adding an if statement later on to skip it, I just made it so that I have this calculation here that doesn't care about the middle one. It includes it, and then I subtract it later. It's a little trick. Okay, so now I can just write let count equal 0, do a for loop with let I equals 1 0 I less than equals 2 and I plus plus. Okay, and now I can say count plus equals world 1 and I. And now I see that this is actually the second coordinate, so I will rename it later on. But now I can say just count minus, well, 1 1, and this should actually still pass. And what I'm going to do is I'm just going to rename this to J because it's the second index. Just for consistency, I'm just going to make this J. Okay. So now that we have done that, we actually should force the other dimension, right? We want to make sure that we also check the other two rows. So for that, we actually should add one more cell, one more test where the cell has two neighbors alive. And the way I do that is, well, I could actually write it like copy and paste this test, but it's basically the same test with the same name. So how about we instead we do a data provider, which will be cells with two neighbor examples. So for now I'm just refactoring. I'm gonna just take this, paste it in here. I'm going to say for let I equals 0, I less than cells, the length, and I plus plus. So now I can move the test inside here, and by that once I add to this array further test cases, then we will generate more sub-test cases. And all I'm going to do is I'm going to say like here, oh sorry, I'm converting this to a template string, and here I'm just going to add a test number so that we know which one are we talking about. And this way I can just say that we are going to put the example here. Actually, I should probably inline this at this point. Yeah. Okay. So now we have refactored this test, and this makes it possible for us to write a second test like this. And in this one I'm going to look at the one above and the one below. Alright, so now it actually doesn't work now, but we know what to do, right? We just duplicate this line, change it to I, here as well, and close the brace, and done. Okay, so our count neighbors function is done actually. Well, for now, because like it still only works for the middle cell, right? Okay, so now that we are done with this one, what's the next logical step? Well, there are still a couple of things missing. One is that we don't check if we have 3 neighbors, then a cell stays alive, right? So we actually should have an extra case here, and we don't check if there are more than 3. So I'm just going to add more of these. So I could say that like have 2 neighbors examples. How about, because our next test is going to be with 3 neighbors, but it's basically the same test, we could just rename this to examples of surviving cells. And if I do that, then I can say specify that a cell with 2 or 3 neighbors stays alive, case and case number. So this was just a bit of refactoring, because like I don't want to duplicate this test all over again. I can just add one more case here, and this actually should do the trick, right? And then I should actually, like, it's pretty obvious that we can just say, instead of equals, we say larger or equals to. Alright, but then of course this is not good, because we should also make sure that a cell with more than 3 neighbors doesn't stay alive. So I'm going to duplicate this test here and say that we specify that a cell with 4 neighbors and then we add 4 neighbors, and obviously it's like dice. No, I mean dice. Alright, so then we can go here and say, okay, so now of course it's either 2 or 3, so how about we just say we were too early here. To simplify, we can say that this is the count, and once we have the count, no, and we can say that it's either count equals 2 or its count equals 3. Now of course I deliberately chose to write it here, but actually, like, this is not good, because the alive, because of the next test, which is going to be a cell with 3 neighbor spawns, right? So I'm going to put this here. We specify that the cell with 3 neighbors spawns. Here are the 3 neighbors, and it's going to spawn. Okay, so and actually this shouldn't be as empty world. I guess I have done that a couple of times, right? So let me just fix this. Our new world. Okay, so let's first fix this, and we can go back and rename variables. Okay, so how do I fix this? The way I fix it is I cut this out of here and move it out here, and that's it. Okay, so now let me see, is there any other place where I have a stupid name? Like, no, that's correct. Oh, okay. Okay, this actually, I didn't have any stupid names. Great. Now if you think about it, like, this is the entire rule. If there are 2 neighbors and it's alive, or when there are 3 neighbors, then it's going to be alive in the next generation. That's all the rules. And we also have the counting here. So we are almost done. The only problem that we have is that once the cell that we are looking at is not the center cell, then it doesn't work. So we actually should write a couple of other tests. And one test that we can write is specifying that an edge cell is an edge cell spawns with 3 neighbors. Let's see that example. It sounds like an interesting example. So what I'm going to do is, okay, I forgot to add this. Okay, so what I'm going to do is I'm going to have just these 3 cells down here, and I'm going to say that this cell should actually spawn, right? And it's a new world. Okay, so of course it's failing, and now I am trying to make this work. So how do I make this work? Now of course there are a couple of things that I now need to do before I can fix this, because I would be tempted to just copy and paste this part, but for this part to work I actually need to count neighbors in a smarter way. We actually need to have x and y's in there. So what I'm going to do is now I will do a refactor that won't change behavior, but it's going to make it easier for us to satisfy this test. So the way I'm going to do that is I'm going to say that here this thing is actually, it depends on the x and the y, and the way it depends on the x and the y is that and I'm going to pass in 1 and 1 because this whole thing is about the 1 and 1 cell, so that's how it should look like. And if I do that, then what this is actually, it's x minus 1, right? It's 0, but it's actually comes from x minus 1. This 2 actually comes from x plus 2, and here as well, this one is y minus 1 and y plus 1. And that's how, okay, so it fails. Why? Oh, because this should be 1. Okay, so that was the problem. All right, so now it's actually working, and now I can come in and just re-enable this test. And what I need to do is just get this thing, copy and paste it, modify the first to 0 and 0 and 0, and that's it. Bam, it fails. Why? Count has already been declared. Oh yeah, okay. And it still fails. Cannot read property of 0 of undefined. The reason is, so here, if we console log here again, just like before, let's see what's happening. Aha, so we have a minus 1, and that's obvious because we start with a 0 and it comes in here, and of course the index cannot be minus 1. So how do I solve that? I just say if I in log, and that's it. Now it should work. Oh, it works for most cases, but not all of them. Oh yeah. So let's look at this test case. This one here, and yeah, this third test case. So what it says is that we are expecting the middle cell to be alive, but actually there is one more cell, this one, that is alive, and that's actually correct because it has two neighbors. And here's the thing, what I did wrong here, and that was kind of deliberate on my part because I've seen that error made by many people, by many people, is that we have went with the same example as the first one and kept asserting for the entire board, when actually we were only interested in the center cell, right? So this, here what we say is empty world evolves to empty, and we actually check that. But here we say that a lonely cell dies, and we should actually only check if the middle cell is dead, and not check all the other cells around it. And this is what kind of still works here, because coincidentally the other cells are actually dead. But here it breaks because, yeah, this cell is actually going to stay alive. So how do we fix that? Well, what I'm going to do is I'm going to go through all of the tests that we have written so far, and I'm going to fix each one of them to only check what we actually claim that we check, and get rid of the over assertion problem in general. So here what we actually want to check is that the 1 cell in the evolved world is alive. No, is dead. Right? This is the only thing we want to check, nothing more. And if I do that, then I don't even need this anymore. Okay, so that fixes, oh no, it didn't fix any tests. But now I can go through and fix all of these. Here it's alive. And then going on to here it's going to be dead. Just have to copy it in here. Then in this one it's going to be alive. That's starting to fix the test one by one. Here we don't need this as well. And then we have this one here, it's going to be dead. And this is the last one. And here we are actually checking the 0-1 cell to be alive. And that's all we want to check actually. Okay, we still have one test that is failing. Ah, I see the problem, because this should actually be X and Y. That's the only part where we forgot to modify that. Okay, now it's actually passing. Now, of course, this is code duplication. We want to get rid of code duplication all the time. So I'm going to say that for flat I equals 0, actually it's 0 and 1, so I can say I is less than 2, I plus plus, and I'm just going to move this in here, and instead of 0 here I'm going to say I, and I, and then I don't need this part. That was a nice little refactor, and now it's kind of implies what we need to do next, because this 2 should actually be, or this should be actually less or equal, and actually it should be the length of the world array, right? So we could just say that. Okay, so I'm going to replace that with the length of the array. But to do that, I'm just going to write a test where we have 4 lines. With the last line having 3 items. And I'm going to check that last 0, 1, 2, 3, the 0 middle cell to be alive. And it's not working, of course. Cannot read property of 1 undefined. Okay, this is not how I expected this to go down. Yeah, so there are several problems here. Okay, let's do that in 2 steps then. Let's first say that it is 2. So now it's just not correct. I can fix this by saying that this should actually be the world length. Okay, but there is actually one more test that I need to write, and that is we have to specify that the height of the world equals, or the new world is the same as the so, and of course, like, I want to be fair here, so for now I'm just going to actually test that. And here I'm just going to say that this dot length to be 4, and of course it fails. And the way I fix that is by just doing this. I'm going to remove this whole thing here. I'm going to start out with a new world that's empty, and here I'm going to say that new world push just push array of zeros on there. Okay, that works. Okay, then what's next? The next is, of course, right now everything works except for, like, we don't calculate the corners. So the next cell with 3 neighbors, spawns, and I think we should go with a corner cell next. And I'm going to just write something like this, right? And then this 0 and 2 cell should be alive. Okay, so now I can just say here I should have a for let j equal 0, and then j less than, well, for now 2, and j plus plus. I'm just going to do j here, and j here, and j here and just close this part. Okay, that doesn't work. Oh yeah, because I forgot to open the brace here and close it here. Okay. Okay, this didn't fix the test. Oh, obvious, again, the same error, right? We actually also have to check if the J is in world I. And that's okay. Okay. It still doesn't work though. Oh yeah, because it's a 2 and 0. Okay. Right. Okay, it was the wrong test. Okay, so now I have this cycle in here, and I'm just going to do a bit of refactoring because it feels weird that we push an array here and then modify it. So I'm just going to say that this is going to be a variable line. I'm just going to move this over here, and then instead of modifying the new world here, we are going to say line. And actually another refactor that I'm going to do is no, I cannot do that yet. So the next test should be that we can have longer lines. So simple test, we specify that the width of the new world is the same as the width of the input. And the way I'm going to do that is I'm going to have a really simple world with just 5 empty cells, a single line, and I'm gonna check if this is 5 indeed, the world, evolved world 0 length. So that fails. The way I fix that is by replacing this with an empty array, and then instead of modifying that cell, I'm just going to push it online. Well, but I will also have to push it when it's dead, right? Because now that's how we add them. Okay. Oh, interesting. Oh yeah, because because we are only going to 2, so that actually means that we need to modify this to 3. Okay, and that still doesn't work because it's the world's length that actually matters. Actually, the world I length, so it's the width that actually matters there. Okay, so now everything is passing, and I want to do a bit of refactor because this is not so nice as a code. So I'm just going to take this here, extracting to variable should stay alive. Then I'm going to extract it further to function scope stay alive. Okay, I can inline this one here. and I can inline this one here, and now I don't have name clash, so I can rename it to should stay alive. And maybe I can create a ternary operator here, so instead of saying if this, then push one alive, otherwise push that, I'm just going to say I'm going to move this thing right in here with a ternary operator because it looks nicer. And that's it. And actually, at this point, our code base works. We have everything that we need. We are checking at all of the cells. We have the rule defined here. We have the count neighbors function that does everything we need. And this is actually like almost like an object. I'm just going to move this down here because it's more logical. So what we could have done is to create an object and pass the word in the constructor and then do this whole thing as private functions. But like closures are just like objects. So using closures here, I think it's fine. And just to check, like do a sanity check that it actually works, I'm going to just write one last test. So last test, complex example evolves correctly. I have this example here. I'm just going to create another constant result. I'm going to hand calculate what it should look like, and we'll see if that actually works. This should actually have this result. Okay, let's see what happens. Yeah, and we actually want to check, sorry, this wasn't ready yet, to equal the result. And it works. Great. So that was it.